That's what I'm trying to be because I'm informally measuring until I do it.
I'm not trying to accuse you of
In case of everybody. It's not that So it reminds me of Punch Out. I had 3 graders going up once.
Punch Out made a presentation on Punch Out at BBNT. Punch Out is so year ago. Punch Out. You remember Punch Out? I haven't actually played Punch Out, but like I've seen a million playthroughs of it. I've seen the blindfolded playthroughs at EECS. I've seen like all of them.
Okay, all right. Ladies and gentlemen, welcome to another week of EECS 498, EECS 404, Game Engine Architecture. This is not just another week of Game Engine Architecture, this is your final week of Game Engine Architecture until what? Spring break. Fantastic. Spring break. This is an important week, right? If you don't kind of use this week, right? If you just take your spring break this week, well, you know, Homework 7 is launching and we expect it to take about 2 weeks for most of you. And so if you take this week off, you're going to need spring break, all right? But if you put in a decent amount of work this week, then you'll be able to take spring break completely off. That is what I hope that you will do. Today, our mission in the 90 minutes that we have is going to be to introduce you to Homework 7 and introduce you to the big new topic of Homework 7. I think one of the coolest topics in the entire course. a brand new programming language. One of the most famous languages out there is a classic historical language. It is a language that you need if you want to do embedded programming, if you want to do scripting, if you want to have a multi-language program, then Lua is definitely the language of choice. We're going to be talking to you about what that means and what kind of a language Lua is and what it's like to write Lua code today. If we have time, we'll try and get to integrating Lua into C++. I don't know if we'll make it today, but we'll see. We'll see what happens. How did homework 6 go, everyone? All right, it's kind of like, it's kind of a tough one, right? Yeah, so homework 6 is definitely a tough assignment. At some point, I have to start working the average grade in this course down toward that B that I'm required to target. And homework 6 is definitely one of those tougher assignments that we kind of do that in. The integration tests in particular are very tough. Algorithmically, it's very tough. Getting correctness is tough, and then getting performance to where we need it to be is tough as well. This is all to say I wouldn't feel bad if you ran out of time or if you didn't get all those points that you wanted. You're certainly not alone in that regard, though we did have some students who were able to get them all. We are, a quick announcement, the Linux autograder has been having a rough day at the office. A quick explanation if you haven't heard me say it a few times. What happens on Linux is that the Linux operating system is very strange. This kind of problem doesn't happen on Windows or Mac, but what happens is when the student process, the student game engine process, starts consuming too much memory and too much CPU power for too long, there's a chance the Linux operating system will kill the processes that are running. Now, this wouldn't be a problem if Linux killed the student autograder, the student game engine, right? Because that just results in you failing the test case and that's it. Instead, the Linux operating system, the kernel, decides to kill my autograder program, at which point it will get relaunched. But every time we relaunch the autograder program, it has to re-prepare, right? It has to prepare an assignment again. And that can take, 10, 15 minutes. And then it runs the student code again. If the student project is not very performant and it kills, it causes Linux to kill the autograder again, it can get into a boot loop. So the solution here for me is usually going in and just hard resetting the Linux box in the cloud. And that usually is enough to start getting people through again. But in any case, the deadline for homework 6 has been pushed back to 8 p.m. So this is basically just to try and help people who are stuck in the queue today. It didn't feel very fair because of a technical issue that the Linux autograder was kind of stinking up the joint. In any case, it's kind of a double-edged sword to get that extra time, isn't it? You thought you could leave homework 6 behind, and then it's back. You got about 3.5 more hours of homework 6. Okay, just when you thought you had escaped, you have a few more hours to try and grab a few more points if you want to. I wouldn't blame you for just calling it a day, though. Okay, let's talk a little bit about one of my favorite game engines of all time, a very famous game engine. If you were growing up in the late 90s, early 2000s, if you were part of kind of early internet, web-based gaming culture, then you probably heard of Flash games. You might still these days hear of Flash games being used to refer to games played in your browser, even if it's not using Flash. Flash was a really cool web technology that powered a lot of web multimedia in the days before HTML5. HTML5 brought in the famous canvas element, which made it much easier to create two-dimensional multimedia games, films, using JavaScript. Before that era, you had to basically install a plugin, whether that plugin was Java or Flash Player or something like Microsoft Silverlight. Your browser was generally not capable of playing 2D games like the kind of which you see on the EECS494.com. Okay, this game up here is HTML5 with JavaScript and WebSockets. and these are open technologies that every browser has, every major browser. In the early 2000s, it wasn't a thing. So you would play this via Java plugin or via a Flash Player plugin. Unfortunately, Flash Player, it was purchased from Macromedia by Adobe. Adobe kind of did some strange things with it, and I'll say Adobe is not my favorite company, and I wonder about their competence sometimes. But Adobe was never able to make Flash secure, and it was never able to make it very performant. And thus, Steve Jobs penned a very famous letter. Let me see here. Steve Jobs murdered it, all right? Cold blood. Steve Jobs decided that Adobe Flash had no future on the iPhone and on iOS and on iPad. And that basically put Flash's days were numbered after that. And so I want to show you why Flash was really important to people. I want to show you some of the famous games and videos from that era. These are some of the things that I ended up, watching when, NG Guard, what's this? This is newgrounds.com. If it looks like a crazy punk internet media site, it's because it is. It has games, it has audio, artwork, whatever you want. Just tons and tons of games, quite cool games too. And a lot of very recognizable characters kind of were born out of Adobe Flash. Super Meat Boy, Alien Hominid. Have you ever heard of a game called Friday Night Funkin'? That is Newgrounds. Like, that game's soul is Adobe Flash. And so a lot of the spirit of that game comes out of that era. Armor games, right? Lots of cool websites. You just go online. Maybe you were bored at home. Maybe you wanted some free games. You couldn't afford some games. XGen Studios. Maybe you were at the high school computer lab and you finished your assignment and you had some extra time. That was what we did. And Albino Black Sheep, I probably won't click on this link on the university Wi-Fi. There's some stuff on Albino Black Sheep, okay? But I'm going to show you some of the most famous Adobe Flash animations from that era. And even if you don't like it, I think hopefully you'll get a feel for what the culture was kind of like and what passed for humor. It was very edgy. It was very fun. I still think it's quite fun. This is the Evil Strawberry. Early indie animations, one person usually, animating in Adobe Flash in their spare time. Let's take a look. Evil Strawberry.
You want strawberry? You can't have it.
I want to have it.
You're a stupid baby man.
I want a strawberry.
You're stupid.
I'm not stupid.
Yes, you are.
I'm not. I'm not stupid.
Yes, you are. Oh my God.
Okay, so there you go. If that looks strange, the kind of media that a lot of my generation grew up with, you're a little bit behind me. You're behind me by about 10 years or so. The millennials were, I think, one of the final generations to truly know a pre-internet age. And in the early era of the internet and multimedia on the internet, this was crazy. And what's really crazy is that this was available for free, right? Random people were making and building up their art and animation skills by using Adobe Flash to really easily make animations. I'm going to show you maybe a more famous one, Ultimate Showdown of Ultimate Destiny. Let's take a look. And trigger warning on this one, blood and seppuku.
attack. Didn't expect to be locked by Shaq. To open up the show. And that great power came out of the blue. Reading should keep the deal. And they both got back to the back. Abraham Lincoln popped out of his grave and took an AK-47 out of his hat. And away with it out of his hat. But he ran out of bullets and he ran away because of this crime and save the day. This is the shutdown. This is the gas back at explosion. See it. Survive the thing. This is the shutdown. Ultimate destiny. Took a ride out of his prime. Like scrub the guns and look about another crime. That Shaq came back covered in his iron track. But Jackie Chan jumped out on it on his back. The Batman was injured and tried to get steady when Abraham Lincoln came back with a machete. But he saw the cards when he did it. He had to then he saw God's and sneaking up behind. Then he reached for his gun, but you just couldn't find. Because Batman stole it and he shot and he missed. Jackie Chan deflected it with his fist. Then he shot to the end of it. He hit the star saw one Abraham Lincoln shot. On the hospital's crime, but they got it here. And they got hit by a huge snare. This is the shutdown. This is the new explosion. See it. Survive the this is the shutdown. Angels say in an immaculate death from the heavens, descent chugging north. We delivered a kick to shatter bones into the crotch of Indiana Jones. Fell on the ground, fighting in pain. As Batman changed back into Spain, saw through his clever disguise and crushed Batman's head in between his thighs. Then get up, and get up, white, and not to come and with the Black Knight, and he to Mussolini, and Mussolini, and Captain Clark, Curtis, and John P.T. Cops, Terminator, Captain Kirk, Superman, Superman, every single Power Ranger, as Preston, and Victor, no, it's not wrong, no, came out of nowhere, lightning fast, and they kicked your bones, and now I gas, so it was battle, and the world was up, against the guys, and rich took for a century, many lives are claimed, but eventually the champion stood, the rest all better, it's Mr. Rogers in a bloodstained sweater. This is the shutdown, this is the gas back at explosion, see it, this is the shutdown, this is the
Okay, right. So a very edgy time, a very fun time. And this is the kind of thing that you would find just an endless supply of. New animators and musicians and artists and game developers just trying to make interesting stuff and release it for free on the internet. It is really, really good stuff. But Apple kind of put Adobe Flash into retirement. Adobe kind of did that themselves due to their inability to make Flash Player kind of and secure. There were just constant updates, and they were never very good. They rebranded Adobe Flash as Adobe Animate, but they have now sunset Adobe Animate, and now that's going goodbye soon as well. The development experience was really, really something special. It ran in web browsers via the Flash Player plugin, and it used something called ActionScript, which you can kind of see an example of here. It is, vaguely similar to JavaScript. You have event listeners, you got functions, you got everything you need. You got variables. It was an object-oriented programming language. What was really, really cool is that there was a really nice editor in which you could be animating and creating art 1 second, and then just a moment later, you could be adding script that would run at certain moments in the animation. And so you can kind of see an old video tutorial on building stuff in Adobe Flash. Let's take a quick look here. Just so you can see the UI and what it was like.
In this video, you will learn how to animate in Flash, even if you've never opened the program before. And if you'd like to download the animation located on the right side or on the bottom,
Okay, blah, blah, blah.
we want the player to like a new
you have a canvas. You can start drawing things just like that, right? Here we go.
If you're filling in your character with white, you'll be able to tell that it's filled in. Okay, so let's talk about drawing stuff. This is the fun part. So we're going to select.
So some of Adobe Flash's drawing tools, despite Adobe also making Illustrator, have yet to be surpassed, in my opinion. Adobe Flash was a vector art program. It didn't really use bitmaps very much. And so what does this mean? Well, it means it's much less performant than bitmaps would be. But all the art is turned into math at the end of the day, mathematical expressions, which means you can zoom and as much as you want, and the game remains as crisp as you want it to be. You can create these beautiful objects. You can really quickly create characters. You can move them around, turn them into objects. You can animate them, parent them, shade things quickly. It was just really, really something. I want to show you what the end result is. You've got this timeline right here, so all the EECS 298 students know what that's for and how that works, right? You can be creating characters one moment, you can be animating them next, and then you can be adding game logic in the form of action script right after that. So we can see this final animation right here.
So let's animate this guy. Let's get him from the start all the way up to the top. So now we finished our animation. Let's export it as a video so we can upload it to YouTube. So to export a video from Flash, we're going to...
It was awesome. It was completely insane. It was absolutely fantastic, and I miss it very dearly. No engine except perhaps UbiArt have really seems to have kind of hit this niche. Flash was very important not just for web games, though, because long after the deprecation of Flash, a technology called Scaleform was still going very hard in the industry. So Scaleform was a technology that let your C++ game engine ingest Adobe Flash files, and you could use them as UI. So a lot of the big AAA games from the last several decades were actually written, they had their UI written in Flash. I'm fairly certain The Sims 4 had their UI written in Flash as well. It was simply just so nice to animate in and to work in. So a lot of the Quiplash, the Jackbox Party Pack games, as far as I know, they still heavily use Adobe Flash as their main development tool and engine for most of those games. So it really is, I'm very, very sad it's gone. Okay. Anyway, I will stop. The last thing I'll say is that a good few of my games from that era are out there, but I'm kind of embarrassed by them, and so I won't tell you which ones they were. But we did have quite a few players in those early days. My first money from game dev ever came from my crappy Adobe Flash games. So it's very near and dear to my heart. My second ever engine after GameMaker, which we'll talk about more during our final lecture of the semester. Okay, Hacker News. I saw this item on Hacker News. It's a little article. The importance of actually making games during a game engine's development, i.e., you need to dog food your work. What do I mean by dog food? Well, if you are working at Google on the Gmail product, you'd better use Gmail yourself. Why? Well, you should use Gmail so that you know what it's good at, that you encounter bugs, and so that you act as kind of a first filter for what do users want, what do they need, and figure out what the problems are. If you read through this Y Combinator Hacker News thread, you can kind of see everyone discussing this. This person right here is mentioning that, the team who made Blender used Blender to make their own films, and that's part of why Blender is so nice once you know it, and so fast. And I actually, a few days ago, I had this situation as well. I'm making, actually I didn't finish it, but this semester there's a new test case in Homework 7, test case 7C3. Suite C is the final test suite of Homework 7. There are quite a few suites in Homework 7. And it's a big, fully featured little tiny mini indie game. And as a result, I actually found some bugs. I found a big crashing bug in our Homework 7 staff solution. And I was able to fix it really quickly because of that. But I wouldn't have found the bug if I wasn't trying to make a legitimate game with these tools. Another thing is when you try and make a game with these, with your engine, you discover that, oh shoot, I actually need some features. I have to add additional features. Otherwise, it's really annoying to make the game I want to make. So the first semester we designed this course, I was making little games like the Donna mini game, the Shmup, the Cute 'em Up. And that helped us understand that there are certain features we have to add. Like on homework 8, you have event bus. On homework 8, you're going to introduce onDestroy as a lifecycle function. And some other things that you'll create in homework 7 and homework 9 as well. So I'm going to show you this 7C3 test case. We'll probably have one of you come up and play it and see how you do. But let me see here. Yeah, I think that's all I want to say for that for now. Anyone have any comments or questions? Do we have any Adobe Flash fans here? Did you use Adobe Flash for something when you were younger? Probably.
I just consumed it.
Just enjoyed it. Yeah. Yeah, I'll tell you, it was a dream to work in. It was really nice, and I'm actually shocked that Adobe didn't keep Flash Professional, the editor, where the magic was, and just have it export HTML5 stuff. What's the problem? Like, couldn't they not figure that out? Was there no demand for it, they thought? As a result, an entire generation of indies got wiped out for a long time until Unity became popular. And Unity doesn't fill the gap. It's a new great thing, but it doesn't fill the gap that Flash left. So, sad. All right, I want to talk about homework 7, okay? This is the big one. I love homework 7. I think you will like it too once you understand a few important things and figure out the first few test cases. The first few test cases are all about structuring your code, and it's really going to set the foundation for the rest of the test suites out there. In any case, we are sick of this top-down adventure game that we've been hanging out in for a long time. We are sick of having our gameplay logic hard-coded into our engine. Okay, we don't want a moddable adventure game. We want a genuine game engine that can do cute 'em ups, that can do racing games, that can do whatever kind of game you want to make. So we have different genres up here on the screen right now. We have very different logic that means. However, over here in homework 6, we are hard-coded. This is the only kind of game that you can make in this engine. It's not really a game engine. It's an adventure engine. Now, this week, we're going to be using Lua to externalize our logic. In past assignments, like homework 4 and homework 5, you externalized the map design, you externalized the actors and the dialogue, and you externalized the music, the cutscenes, and the images and characters. But now we're going to finally take that next big step, and we're going to externalize logic as well. This week, we're going to have a new language and a new architecture for handling all of this in your code base. So we're going to use that component, that composition-heavy architecture we've been talking about for the last few lectures. If you understood what we said during those lectures, it's going to give you a big leg up on homework 7. All right, this is a 2-week-long assignment because we think you're going to need that much time to kind of come to understand Lua and its unique ways of doing things, and to figure out how to get that component architecture working in your code base. And we're going to help you with all of this. We've got lectures that are going to give you example code, kind of show you what you should do. Not everything, but as time goes on, we'll show you more and more stuff. The architectural changes that are going to take a little bit of getting used to is that now, instead of having, this set, hard-coded, well-known series of properties like blocking, vel-x, transform x scale, right? We need a way for our game designer to introduce arbitrary new properties and to decide how those properties affect the game itself. And so, when you look into files now, like your scene file, you are used to seeing a bunch of actors, and you see one of those actors here, too. This entire chunk I've shown you is one actor. You can see the comma here. in the bottom left corner, you can see that there's more actors. This is just one of them. Now, this actor, whose name is Donna, has a object as well as a name, and this object is called components, and it has a bunch of keys in here. 1, 2, 3, 4, 5. These could be anything. They could be names, whatever. And each of these keys corresponds to an object, and that is the key, and the object is a component. Okay? A component has a type. For instance, this transform component representing basically, it's a component that's very common. In Unity, you have to have it. Every game object, every actor in Unity has to have it. The transform is usually, as you know, for storing your position data, your rotation data, your scale data. But that's not the only component. We have a Donna component. Who knows what that does? That's going to do something very specific to this game object. It's the name of the character, after all. We have this component, keyboard control, and it has a parameter called speed, which is set to 6. This is a very reusable component because maybe Donna, i.e. the donut pilot, the girl in blue, right? She can move around with the arrow key controls, but we might want something else in the game to also move around with arrow key controls. Maybe an ally character, or maybe a cursor to move through the menus. And so if we have this component type, keyboard control, we can slap it onto as many actors as we want. We can slap keyboard control onto Donna several times if we want to. We can give her multiple keyboard control components. And those components are going to be identified. Even if they have the same type, they're made unique and identified by this key, the real name of the component, the ID of the component right here. We have Donna animation to take her sprite and change her sprite over time. We have a sprite renderer that is going to be responsible for actually rendering the final image that we decide she wants to be. These components all work together. They grab references to each other. They manipulate each other at runtime to make the components do what they need to do. For example, this Donna animation component is going to immediately grab a reference to the sprite render component, and then it's going to start swapping out what sprite it is supposed to render every few frames that go by. If you look over here, you'll see that we now are going to have a special folder within your resources folder called component types. And this is going to be a folder where we actually get to decide what is keyboard control. How does Donna animation work? And the way we're going to decide that is that it is a Lua file. We're going to use the Lua scripting language in order to make that decision. You can see that each of these types, each of these components has a type, and each type corresponds to a particular file, a Lua script in your component types folder, okay? So let's dive into one of these right now. Let's look at some of your first Lua. If you look at this keyboard control component, that is a component that needs to do things. Otherwise, it's pointless. Why even have it? When you open up the keyboard control.lua file, you're going to see that, oh my goodness, we got some Lua code here. And this is going to look really weird until you realize a couple things. Lua tables, this is called a table, this big chunk here that you've got. You see this open bracket, this closed bracket. That is what defines a table. Well, a table in Lua is a JSON blob, kind of. It's a somewhat more luxurious JSON blob, whereas a JSON can have values of strings and integers and stuff. Lua can have that, right? But it can also have functions as its data type. It can have other tables embedded inside of it. It's pretty cool stuff. That speed value right here, you see how speed has been set to 6? Well, this is overriding that speed value, that default speed variable inside of the keyboard control table. And so, if we didn't specify speed is 6 here, then Donna would be moving around with a speed of 3. Does everyone know what I mean when I say Donna? Ever know what I mean? It's that girl on the donut. That's her. That's the game object. All right, that's the actor. Okay, so We have overrides, which is kind of an interesting concept that you're going to have to implement. You're going to have to upgrade also how you deal with templates in Homework 7. So components are how we're going to reuse code. We're going to write one keyboard control component, and then we can put it on any actor in any scene we want, even multiple times if we want to. And so that's how composition is really going to help us. If you don't understand what composition does for us and why we care about it, watch our previous couple lectures where we talk about that in detail. You can compare this method of creating logic to what you see in Unity, right? You have variables in a given component, and those variables are usually tunable. You can tweak them so that the component on this actor works a little bit different than the same component on this actor. Okay? If you look here, we also, very important, you have lifecycle functions. Lifecycle functions are functions that are called by the underlying engine automatically. In EECS 494, we would just, let Unity do this for us, right? But in this class, you need to make that happen. There's a function called onStart within this table. But no one's going to call this function unless you do, okay? You're the game engine developer, so the game designer gets to write that function and just assume that if they call it onStart, capital O, capital S, it's going to run at the expected time. But as the game engine engineer, you need to actually make that guarantee happen at the right time, every time. Same thing with the update function. In Unity, it's called update. In our function, we call it onUpdate, so it's about the same thing. One thing you're going to notice right here, and I'll talk more about Lua's syntax in a bit, but Lua uses curly braces only to denote and delimit an a table, okay? If you see curly braces, you're not inside an if statement, you're not inside a class, you're inside a table. And if you see a function, it's delimited by the function, the end of the parenthesis, and then the corresponding end. Okay, so end is like the closing curly brace and the start of the function keyword. The end of the function keyword is like the beginning of the curly brace. So it's a little bit crazy, okay? Down here, you can see that we have this input dot get key, right? Very similar to your input manager API. And then we provide a write, meaning right arrow key. We then have a then statement, okay? The then keyword is the start of your if statement block. So if statements don't use curly braces either. And the then is matched up with an end right here. And that's your if statement block right in there. And you can see that this is basically the same code as we would write in C# over here. The syntax is just a bit different. Down here, we are applying velocity. And one interesting thing that I'll point out in Lua, do any of you use plus equals to do like addition, or plus plus, or minus equals? Too bad. Okay, that's gone. It's completely gone. If you want to do like incrementation, what you have to do is you do self.transform.x. So some sort of variable equals itself and then plus something new. And that's how you do this. You're going to find that sometimes Lua feels a bit crufty, especially if you're writing a lot of code because you're making your own game. It's just kind of crusty, and you can do what you want to do, but it's just a little bit funky. That's a part of keeping Lua very minimalistic so that it is easier to embed and a bit faster and lesser on the memory footprint. Okay, like I said earlier, Lua is much easier to understand when you realize it's all a JSON blob. All right? You've seen these JSON blobs before, right? Look at these. On the left side, you have a bunch of keys, and on the right side, you have values that correspond to those keys. Sometimes the value is itself an object. Sometimes it's a number. Sometimes it's a string, whatever, okay? Sometimes it's an array. In the case of JSON, these keys and values are kind of delimited and separated by the colon, okay, separating the key from the value, and the comma, which kind of moves you on to the next thing, All right. Now compare this to a Lua table. We have keys on the left here as well. They look a bit different though. These are the 3 keys that are in this Lua table. Okay? And you can tell, right, because the delimiter here is the equal sign. But just like JSON blobs, we have that comma at the end to kind of bring you to the next key after the value is finished. And just like JSON, we can have integers, we can have strings as well. We can also have functions, which is something that JSON can't do. And so this is how your component is basically created. The values are over here. So it's a little bit harder to read visually, but this is mainly harder to read visually because your value types can be much more deluxe, okay, and much longer. These functions have source code inside of them, okay? And so the delimiter for here, for Lua, is that equal sign separating the key from the value, and the comma, just like JSON, separating the end of a value to the next key, from the next key, okay? So you can see the delimiters in here in these red blocks, okay? So some tips for you, and then we'll get a bit deeper into Lua. Try and keep a kind of consistent pace on this homework. It's going to be very tempting with spring break, 6 days away, to not do a whole lot this week, all right? I wouldn't blame you. But you are setting yourself up to either work over spring break when you realize just how many test suites there are, and you're setting yourself up to work on that final week under a lot of pressure. So try not to do that. This is really the assignment where you want to learn a bunch this week, give yourself spring break to kind of let it digest, and then in the final week you can knock it out. Okay, this is a very tough but I think extremely satisfying assignment. You're going to need some time just to get familiar with the language, okay, before you can really start to integrate it effectively and understand what's going on. There are a lot of features that we need you to add, okay, in order for this game engine to be able to actually genuinely do things. Did it sign me out? Are you serious? Why would you do this? Okay, we're good. I want to show you the assignment spec really quickly. So let's go in here. Language hosting. What a crazy assignment. It was quite painful for me to figure out how to make this one myself the first time. But it was very fun as well. Okay, so you have these initial, air quotes, test suites that basically just kind of tell you to do something. It's not going to grade you. One of those is to kind of get a little feel for the Lua language. And the next one is telling you to refactor your code base, i.e., our goal is to remove anything that is specific to the top-down adventure genre. I.e., we're kind of ripping out that Homework 5 and Homework 6 game you've been seeing. That might feel painful, but what you're going to discover is that your code base is much easier to manage and much more elegant and beautiful when you have cleanly separated the gameplay logic into Lua, so your engine can just focus on providing good tools to help the Lua code do what it wants to do. For test suite 0, you're going to focus on loading components in. What does that even mean? Well, in the context of Lua, that means you're going to be grabbing those .lua files with the table in it, and you're going to be adding those Lua tables into the global Lua state. We'll talk about what that means a little bit more in the very near future, and today possibly. You're going to start then focusing on component overrides and properties and inheritance, which is a big deal. The way that inheritance works in Lua is kind of funky. I'm going to show it to you in a bit. I don't really expect you to understand it just yet. Flexible referencing is basically the ability for some components, do you see this code? The ability for components to grab other components. Have you ever heard of this function, getComponent or getComponents? These are functions that are really important to you programming in Unity or Unreal. You use this kind of thing all the time. And so you need to bring that to life. One component in Lua could call this function, self.actor, getComponent, and then provide the name of a component, a type, the type. and you have to return it the component. Okay, you have to return it the component of that type that the current actor has. So you have to do a lot of stuff. You will then get to on update, on late update, and error processing. You will then have to add a lot of functions to your Lua API. Application.getFrame will report what frame of the game are we currently on. What number? It's just an integer. This function, application.getFrame, does not exist in Lua. You have to make it exist, all right? And that's going to be a big part of the rest of the test cases. It's very fun. Application.quit, if any Lua function calls this, then you need to quit the engine, kill it right away. Input, okay? Input.getKey, get key down, okay? Mouse stuff, showing the cursor, hiding the cursor. Adding components at runtime, deleting those components, removing them, okay? Creating actors at runtime. Thus far, the only way to bring new actors into your game is to load a new scene. With Homework 7, that changes. Now, you're going to be able to instantiate and create new actors whenever the Lua code wants to, by calling actor.instantiate. In Unity, this is called gameObject.instantiate, okay? You provide the name of a template, and that template appears just like that, okay? And starts doing its thing. You can also destroy actors at runtime. So some of your accelerating data structures might need to be rethought or removed altogether in order to work correctly with these new functions. It's quite something. You will create code that draws text to the screen. You will create functions that play audio on certain channels, set the volume. You'll have an image table, right? Image with functions like draw UI, draw characters, okay, just normal draw. You'll be working in different coordinate systems to bring these to life. It's not as bad as it sounds, I promise. There's one function called draw pixel, which you can use to draw any arbitrary pixel of any color at anywhere on your screen. What does this mean? Theoretically, you could create a fractal pattern. If anyone has done that in the class, you could create a 3D game engine just using this function. You could recreate Doom if you wanted to. It gives you a lot of flexibility. You have a camera API to help manipulate the camera in the scene. In our engine, you're only allowed to have one camera at a time, which is a nice simplifying factor for us. There's a scene table, which has functions on it called load that allows you to load a scene or get the current scene's name or mark an actor to not be destroyed when you move from one scene to the next. That sounds familiar, doesn't it? Unity developers, okay? And then we have a bunch of integration tests, which are big games, all right? Would you like to play one? I have a game that I was working on. I put about 8 hours into programming it. It's not very fun, but it does kind of resemble a game. Oh, by the way, you're looking at the staff solution. Enjoy. You can use my code if you want to, okay? Don't go finishing the entire project because you saw the source code for the solution, okay? All right, let's go here. Would someone like to play the game? Don't all jump at it at once. I think some of you saw this already. I'm going to rename this really quickly so it doesn't go playing. Okay. I don't want to play it. Who's not seen it? Yeah? Okay. Vadim? You're never going to believe this, but you see this cute 'em up game? Your engine is going to be able to do this, okay? But you're never going to believe this. Your engine will also be able to do this, all right? And more. So, yeah, give it a shot. This game's kind of hard, I think. Okay. I even made a little cutscene for you. See? You can move the mouse around to look around. So this looks familiar, doesn't it? think this enemy looks like Markiplier? Anyone? Anyone see it? Yeah. So one kind of tough thing I had to implement in Lua was the enemies can see long distances, but they can't see through walls. And that was a little bit trickier than because we don't have any raycasting tech in Homework 7. Uh-oh. Rest in peace.
No!
Brave. So you can zoom out with the scroll wheel. You'll have to implement technology to detect the scroll wheel. Doesn't that make the game easier? Yeah, I think I should nerf that, actually. I had to implement some pathfinding because once the enemies see you, they have to accurately be able to chase you down through the map. That was quite a pain in Lua. Run, run, just go for it. No, okay. So, nice. Epic. Good job. Well done. Okay. So, it goes a little bit longer than this. Villy will actually just start chasing you from like word one, from turn one. But yeah, so it's it's a kind of a deluxe game in some ways, at least for this course. The test case for this particular, this is test case 7C3. 7C3, and it has inputs up to 6,000. So you'll do frames. It has 6,686 frames. I tested this on the autograder last night. It ends up consuming about 15 gigabytes of storage space just to produce all of the images for every frame that you'll be tested on in this particular game. So we'll have to see how it goes. I'll show you how this runs. I get killed a few times in this test case. You can actually watch where I get myself in a jam and stop moving because I'm like, oh shit. Now I have to re-record the test case, and I just don't. I think it's downloadable test case though. A quick thing, you know why we have this larger resolution, this wider window for this test case? Any idea? Yeah.
Like that frame. Video comparison.
Not quite. I have no idea how this is going to look when my autograder goes to try and like put yours on top of the staff solution. But this is exactly the resolution I need, 1152 by 512, to put this game, once I add more levels to it, on the top page. This is where I get in the jam. I'm like, oh no. Oh, sad. Put it on the website. So people can play it just in the browser. It turns out you can actually take the C++ game engine and you can run it through a compiler called Nscripten, which will turn it into HTML like WebAssembly files. So you can just put it on a website. It's pretty crazy. So anyway, and I can play the game kind of and mess up the test case if I actually add additional inputs while we're playing it back, right? So this is going to mess things up big time. I think it'll run into we'll run into a wall, won't we? Yeah, we ran into a wall. Rest in peace. I'm sorry. Okay, so anyway, yeah, let me know if you can beat the game. It's not easy. So you can do a lot of really cool things in this engine, and I hope some of these test cases kind of prove that fact. Getting 2 weeks kind of provides a bit of a false sense of comfort. It's going to be very tempting to take the first week off. I recommend you do not do that. This is maybe the most important homework assignment in the entire course to understand, as it feeds very heavily into homework 8 and homework 9. I think it's the coolest assignment in the course, and when you're done with homework 7, you will genuinely have an engine capable of kind of rivaling something like Love 2D or Monogame or Pygame. In fact, I would say it's probably a little bit better because it is a hybrid of the minimalistic engines, right? No big editor tool, no window you look at. But it gives you some things from Unity. It gives you composition. It gives you some other really nice ways to reuse code and a lot of features. I think more features than maybe Love gives you. Well, maybe not. But it does give you composition, which is really good. A model for actors and them having components and scenes and stuff like that. Okay. If you're nervous about the sheer amount of work I just showed you, you should know that every test suite after, I would say, homework 6 or test suite 6 is pretty easy. Like after you get through test suite 6, they start dropping like flies. All right? So don't panic too much. Does anyone have any questions on this homework? The homework assignment and the upcoming lectures will walk you through some of this stuff and help you understand it all a little bit better. What I want to do right now is I want to show you a video, a good video from one of my favorite YouTube channels, Fireship. You might have heard of. If you're into like techie YouTube, then Fireship is very, very funny YouTube channel on a lot of different topics. This is their Lua in 100 seconds video. And this video also explains a couple of the interesting foot guns that you run into when you're dealing with Lua. So let's take a look. Here we go. Hello.
Lua, a fast multi-paradigm scripting language famous for being so underrated. Imagine a language that's easier to learn than Python, while also being faster and more portable than Python. Lua was named after the moon. When it was designed by a team of computer scientists in Brazil in 1993, it's lightweight and extremely fast because its virtual machine maps very closely to C. And when used with its just-in-time compiler, it's widely considered the fastest scripting language in the world. This makes it ideal for embedding into other applications like World of Warcraft or Roblox, for example, where users can write Lua to build their own game features because the language is embedded into the base game. It's easy to learn because it has only 21 reserved words and has only one data structuring mechanism called a table that can represent arrays, dictionaries, graphs, trees, and more. It also supports collaborative multitasking with coroutines. Its standard library is very minimal, but it does have a large ecosystem of packages with the Lua Rocks package manager. To get started, install it, then create a file named .lua. Declare a variable by providing a name and value. By default, variables are global, but make them local with a local keyword. It's a dynamic language, so no.
I want to say that again. By default, every variable you make, every variable you reference is global by default. That is the opposite of what you are used to. What are you used to?
Within the scope.
Exactly. If you are inside of a for loop and you create a variable, that variable is only going to be valued within the for loop. Not the case with Lua. Unless you put local in front of that variable, that makes it local to the normal scope, okay? Keep that in mind.
Type annotations are required. We can then use print to output the value to a standard output. There are no classes in Lua, but anything you can imagine can be done with functions and tables. A function is declared with the function keyword, then closed with the end keyword. Functions are first-class objects, which means they can be passed around to other functions to support functional programming patterns. Now, to structure data, you create tables with braces. A table is actually an associative array, which means the index in any array can be replaced with different values. By default, it uses integer values, and the craziest thing about this language is that it starts the index at 1 instead of 0 like most languages. That gives us a conventional.
This will blow you up, okay? Right? It does not start at 0, it starts at 1. Just keep that in mind. That's the second foot gun of this language.
Array, but we can also easily create a dictionary by giving the keys a string value. Now we can use for to loop over every key value pair in the table. The language is single-threaded, but we can use coroutines to pause and resume a function. Create a coroutine, then use yield to suspend its execution. Now somewhere else in the code, use coroutine resume to continue execution until you get to the return statement. Now if you're a C programmer, you'll be happy to know that Lua has a very simple C API. It allows us to run Lua code inside a C program, or vice versa, run run C code from a Lua program. Now to execute your code, open up the terminal and run the Lua interpreter. This has been Lua in 100 seconds. Hit the like button and subscribe if you want to see more short videos like this. Thanks for watching, and I will see you in the next one.
Okay, all right, cool. So, yeah, very, very good videos. And, you know, those, these in 100 seconds videos are not super humorous. Very funny videos if you check out their other stuff. Okay, what I want to do now is I want to do some programming with you. Okay, program some stuff in Lua together. And so, if you're ever confused about what's happening in Lua, there are a lot of great online interpreters and compilers for Lua that you can quickly just go to in your browser. No need to install stuff or get into the command prompt. This is also, I'll say, a very good way to practice. And if you're ever confused about how something is working or not working in Lua, your AI assistants you can give it what you've tried to do, tell it what you wanted, give it the code you tried, and it will explain what your misconception is and what's going on. So I want to show you some kind of interesting things in Lua as far as it comes to creating classes, okay, and inheritance. And I think this is something that our lectures coming up will hit on again, because it is very confusing the first time you see it. We're going to talk very briefly about a topic called metatables, which is wildly confusing until it clicks, and then it's really not confusing at all. I have myself a typical print statement here. When it comes to debugging stuff in Lua, that's going to be the way you do it. During homework 7, you will need to bring this function to life, debug.log, which if you've ever worked in Unity is an old and familiar friend, okay? But if I run this right now, then I'm going to get an error, okay? It says, attempt to index a nil value, a global variable called debug. There is no global variable that exists called debug. You will need to write C++ code that creates this global table, and it's not that hard, not very hard at all to do that. And so, what do I want to do? Well, let's go ahead and just let's create an array. Okay, I want to have an array of characters. Okay, I have Mario, I have Peach, okay, Yoshi, okay, Daisy, and let's say I have these characters. This is an array. Are you convinced? Okay, this is what an array looks like, because you have to use a table for arrays. All right, you have to use a table for arrays, but you could also use a table for dictionary stuff. So, what's a good example of a dictionary? What kind of thing might we want to have? Let's create a dictionary called favorite foods. Okay. All right. And let's say, what's your favorite food in the city of Ann Arbor? Anyone want to say it? Favorite restaurant? Favorite restaurant? Give it to me.
Pizza House.
Pizza House. I was hoping for no tie. Okay. You want to say it? I should have called on him. Okay, so what we can do is I can write Ann Arbor, and then I can do this. I can do Pizza House. All right? And I think this will run, right? Yeah, I got it. So what about Ypsilanti? I need a restaurant in Ypsi, nearby. Ypsi. Anyone got? Yes.
NetEase Tacos.
NetEase Tacos? Is this Beijing?
Minis.
No, Minis?
Yeah.
Okay. I went to the NetEase cafeteria in Beijing, and it was pretty awesome. Very long line though. So you said Baby's Pizza? Did I get it wrong?
Minis Tacos.
Baby's Tacos.
Mini.
Minis. Mini tacos. Okay. So Ypsilanti. Okay. Minis Tacos. Okay, and let's do one more. Anyone? Who's got a city and a restaurant? Come on, let's go. The slower we go, the less I get to teach you, the harder the homework is. Yes?
Panama City Joe Mama's Pizza.
Is that an actual place?
Yeah.
Oh, dang. Okay. So cool. We got a lot of pizza going on. All right. So, is this going to be okay? We might need. No, we need these. I think. Do we need that? Yeah, we do. We're good. Okay. So you see here that we've used tables to create an array, and we've used the same table data structure to create a dictionary. Let's iterate through this characters array and print the names just to verify it is in fact an array. It won't surprise you to learn that there's a looping functionality in Lua, but it's a little bit stranger than you might realize. So in order to start looping, you're going to start with something like for, okay? Now you need to decide how you want to loop through this array. The usual way that you'll do it is you'll define a variable, I, and let's see, it's a character, so I'll use C. And then you use in and you specify characters. However, here you need to make a choice. You need to specify pairs or I pairs. And I'll show you what the difference is in just a sec. I usually use I pairs for integer pairings. And then in order to finish the loop, we need do. Now we have our block. We use end to conclude the block. All right? Does that look weird or what? Or you're not really defining a variable. We are iterating through our table, and we are defining a key, that I variable, and a value, the character inside, the actual string. And we're also specifying which table we're iterating through and how we want it. This iPairs function is going to allow us to move through this table by getting a number, i.e. what index are we currently at, and the C is going to be the thing inside. So let's go ahead and print these two things. These two variables were given to just kind of see what they are. I can print the I, and then after that I'm going to print C. And let's go ahead and run it. Okay, we print hello world at the top, then we iterate through this characters array. We print I, which starts at 1. Again, Lua is 1 indexed, not 0 indexed. We then print C, which is Mario. Mario is the first character. The second character, index is 2, and the second object is Peach. 3, Yoshi, 4, Daisy, okay? And so we iterate through things in this fashion. We could iterate through numbers, and be a little bit more traditional about this by going for, I think I equals 0, 2, the comma is like a 2 here. We're defining our range, to 10. And then I think it's do, and then end. I don't use this one very much, but we're going to see if it works. I want to see the numbers 0 to 10. And there we go. I see the numbers 0 to 10, just like that. I could print the things in the characters table in this fashion. I'm fairly certain I can. Let's try that. The index, is that going to work? It will. But look what happens. You see what happens? We get a nil. Why do we get a nil?
Is that the equivalent of just like a null pointer?
Yes, that's a null pointer. It doesn't explode. But do you see this? When we put 0 into this characters table, we get nil. When this I becomes 1, we put it into the characters table here, we index in, and we get Mario. Why am I getting nil and then Mario?
It's 1 index.
Yes, a reminder again, the tables are 1 indexed, so you don't start at 0. If you want to avoid that nil, you always start at 1. So now we get what we want. As soon as we get past 4 and get to 5, we are past the Daisy object, and there's nothing to get, so we get a nil. All right. Okay, so you can see that you can do what you want to do. It's just a bit funky. All right. Over here, down here, we need to iterate through this in a slightly different way. Right. This is not really an array. This is a dictionary. So if you want to iterate through all the values of your dictionary, you need to do it in a key, comma, value fashion, where the K is not I. It's not an index, okay? And we're not going to use I pairs. We're going to use pairs instead. We're going to give it the table, use do like normal, and then end. And then we can print, let's do this. I'm going to print K, and then I'm going to print V. And I'm going to run it. Okay, we get hello world at the top. I'm going to get rid of that because I don't really need it. And see, we print the first key here, Panama City, and then we print its value, Joe Mama's Pizza. We print Ann Arbor Pizza House, and we print Ypsilanti Minnie's Tacos. You can tell here that something is wrong. We printed these out of order, as in we printed Panama City and its value, Ann Arbor and its value, and then Ypsi and its value. This is to say, when you're iterating through a dictionary, you don't get that guaranteed ordering. Okay, and it might head down here in any sort of key value setup that it could happen. It could be anything. It's random. All right, but that's something to keep in mind. I want to show you something a little bit fancy. I want to prove to you that classes, instances, inheritance is a thing in Lua, and this is actually an extremely important thing to know because the way that you create, you instance your component types is via inheritance. The way that inheritance works in Lua is very particular, and it happens to be absolutely perfect for what we need. So, how's it work? And I take this pause because I'm trying to think about it in my head. It's been like a year since I've thought about this, okay? All right, so here's something I want to do. I want to create a table. We already created a couple tables, but I'm going to create a table with a particular name. I'm going to call this table character. And here we have our table. Do you agree? Now, we can put numbers into this table or strings like we did previously or key value pairs. I want to do those key value pairs, okay? My characters in my game should have a health value, HP. By default, it is 100, okay? Our character should also have a speed value, which is going to be 10 by default. Our character should also have a name. And by default, I'm going to give it question marks because, you know, the name should be defined by the person creating the character. Okay, so do you agree? This table looks very much like our favorite foods table thus far. What I'm about to do is kind of strange, all right? I'm going to create a function called take damage. Okay? Do you agree this is a key? Instead of having a value of an integer or a float or a string, I'm going to give it a value of a function. All right? And I'm going to end that function right here. Now, this function is meant to be an instance function, a member function. If someone calls this function on a character, we want this health to go down by a certain amount. This implies two things. I need two parameters here. I need a self reference, and that's going to be a bit confusing for you, probably. And I need an amount to damage. So let's call this damage amount, okay? Why is this self-reference here? This self-reference is a key word, okay? You can tell because it lit up in blue. It's a special word. It's one of those limited 21 key words that Lua gives you. You don't have many of these, but you have some. Whenever you have self is going to give you a reference to the particular table that you are currently operating in. In other words, the way that a lot of languages work is that when you call an instance function in C++, all right? Hold on just a second. I'm going to show you an example of this. Let me go into main, okay? Do you see this function called game loop? This game loop is an instance function. It is not a static function. A static function doesn't need any instances of the class to operate on. A static function is just a function associated with the overall class itself. Now, this is and we can actually look at the declaration to see this, right? There's no static here. It's just a normal instance function, a public instance function. You have to create an engine instance in order to actually call this function. And here we do that. We create the engine variable, the engine instance, and then we can use that instance to call this function. Well, What's actually happening under the hood here is we are calling the game loop function of the engine class, and we are sending in this particular engine that it should operate on. This is the self-reference that is being implicitly passed into the function when you do this little dot, okay? And so the takeaway here is that every language that allows instance functions that operate on the data within one object of a class has a self-reference. And you might actually have heard of this before. You can actually find it explicitly if you've ever used this. You know what that is? That is the self-reference, if you need it. The compiler in C++ is an awesome compiler, so you don't need to use this, but you can. You can actually just type render. You don't need to do this render. You just type render, and the compiler automatically knows what you're talking about and what you want. Lua doesn't know, okay? So the way that Lua wants you to do things is it forces you. If you're making an instance function of a class, you need to specify that self parameter. And anyone who calls this function needs to send it in, okay? 2 parameters to call this function. The parameter for the amount of damage that should be taken, and the object, the table that should take that damage. We might have many tables, we might have many characters. So which one is taking damage today? Okay, anyway, so when we take damage, we need to adjust this HP value. If I write HP equals HP minus damage amount, I have a massive bug. You know why? Tell me about this HP variable right here. Not this one, this one.
Something you have to reference self, or else that's
yes.
a variable.
This is a global variable. Okay, this will be interpreted as a new global variable you're creating called HP, global to the entire program. What we actually want is self.hp. That is how we refer to this particular variable right here, inside the current table. Okay, the function is now complete. All right, but how do we create a new character? Well, here's a way to do it. It's very funky, but hang with me. We need to create a constructor. You can also think of it as a factory method. So here's what we're going to do. I think it's a kind of a standard to do this. New, new equals function, and this is not going to have a self-reference because this is going to create us a new character instance. And I'm going to say we need to pass in a name. And I'm going to conclude our function here. If I forget this comma, because remember, a table is a key value store. It's a JSON object. If I forget this comma, this crash. This doesn't work. This is not valid Lua. Now it's valid Lua, okay? So here's what I'm going to do. I'm going to create a local variable. I'm going to call this new character. And it's going to be an empty table. Now, I want to give this character, this new character table, this is just a purely empty table right now. I want to make sure that it inherits from the character table that we're inside of right now. So here's how I'm going to do it. I'm going to use a very special function called setMetaTable. Okay? I want to set a metatable for this new empty table. And the metatable I'm going to give it is this table right here. This is a table, okay? In order for it to be a useful metatable, I have to give it this unique property, __ index, and then I need to tell it I want character to be my index. Okay, what on earth is going on in this line? This is crazy, okay? Maybe I can draw it. Well, I don't want to draw it because then everyone online can't see it. I'll try and explain what's happening, okay? This line of code creates a table. And there's nothing special about this table at all. This table we just created right here, it's stored in new character, has nothing to do with the character table yet. That's very hard to understand. Okay, it looks like, oh, we're creating it inside of the character table, right? Yes, you're creating it in a function that's inside that character table. That's all you're doing, all right? Nothing else special. We're creating this completely empty table. There's nothing special about it. Now, in Lua, a table, any table, can be given what's called a special meta table. A meta table is just another table that might have some special keys inside of it. One of those special keys is index, and character is basically what we're setting the index value to. Index, and this is kind of a really unfortunate name, index is what tells Lua who the parent table is. Okay? So we now have an empty table with nothing in it, but we have given this empty table a meta table. The meta table is literally right here. It's in my highlight right here. It's a table because you can see the brackets, can't you? And it has one key in it, underscore underscore index. When you do this, if you ever try and get a variable, a value out of this new character table, what's going to happen is it's going to look for that variable. And if it doesn't find it, it's going to see, oh, okay, we are indexing from the character table. And it's going to look for that value in the character table. And if it finds it, it'll return that. That's kind of sort of how parenting relationships work in other languages, right? You're going to look at the child object, and if you look for something in the child object, but you don't find it, the parent might have it. So you look in the parent has it. Boom, return it. Now, this kind of raises a question. What happens if you write a variable? What happens if you try and change the HP in this little child table? The child table doesn't have an HP value. What's going to happen, though, is that it's going to try and write a HP value. It's going to see that it doesn't have one, but the parent does. And it's going to give the child a new HP variable. It's not going to clobber or change the parent's HP variable. So it will read the parent's stuff and use it if it needs to, but if you are creating and changing that variable, it will give it to the child as a completely new thing, new copy, okay? All right, that was super confusing, but all you need to know is that this is how you set up inheritance in a new table. And this is what constructors in Lua tend to look like. One moment, William. So we've set the meta table. We should probably make use of this name that we just did, right? So let's go ahead and go new character. Let's go new character, I think, dot name equals name. And then we need to return this new character that we've created and this new table. So it's very easy to mess this up. So we need to go ahead and do some experiments. I want to create a new character. So I'm going to go character. That is the table, right? And I want to call the new function on this table. So I'm going to call new, and I need to provide that new function with, look at the parameter, a name. So here is Mario. This function is going to return me a table that has been set up with inheritance, the parent being the character table. And so I can go ahead and put this in a variable. So local, let's call it C1 for character 1 is Mario. Local C2 equals character new. We're going to create Peach. Okay? And this is how you can create two brand new characters as if you were in an object-oriented language. And let's just, let's test this. So I'm going to go C1, and then I'm going to go colon. We'll talk about that in a moment. Take damage. How much damage should Mario take? Any idea? I don't know, 10, okay? C2, Peach, is going to take 20 damage. And now I want to print, you know what I also want to do? I also want to put C1 and C2 into a table. Let's have a characters table, And I want to put these characters into that table. Let's do this. Okay, how do you put a character into a table? How do you put one table into another table? How do you put anything into a table? You write table, this is a keyword, dot insert. Okay, and then you provide the table you want to insert things into, and then the table you want going in. So C1, I want to put C1 and C2 into that characters table. So create the characters, and then I want to add them into an array for safekeeping. We can then do damage to the characters, and then we should be able to iterate through them. So let's do this. For IC, for index and character, pair in I pairs, let's call this characters. Let's go through the characters table. Do end. And I want to print, let's print the index, and then concatenation operators dot dot. Don't ask me, okay? And then dot dot C dot name. So we'll print the name of the character, and then let's go HP, and then we'll print the HP of the character, so C dot HP, all right? Oh my goodness. That's a lot of code, all right? Look at that. It's perfect. Do you see it? We were able to create a Mario character with an HP, with a speed value, with a name, and we were able to create a Peach character with an HP, with a speed value, with a name, and we were able to edit Mario and edit Peach with different damages they take, and it looks great, okay? We can put them into a table for safekeeping, and we can iterate through that table later to print stuff. You can do a lot of stuff, all right? But I would say that inheritance, what's happening in here is going to take a while to understand. There's some keywords you haven't quite memorized yet. You might not realize that this is just a metadata table that we're sticking onto this table. That metadata table has a particular keyword it uses to establish inheritance, and that when you have established inheritance, you can edit this table. You can add new stuff. You can overwrite values. You can read values. If you're reading values, if they haven't changed, you'll read them from the parent table. If they have changed, you'll read them from this table. Okay, goodness. This is all to say inheritance, it just works. It's going to be fine. All right? Yes?
All right, so on the meta table, so this index thing equals character is in itself a table, right? Does that mean that...
This is, hey, William, look at that open bracket. Look at that closed bracket. That always means you just made a table. Okay? And that table, you can mess with it like any other table. So, you know.
So does that mean if new character is missing a value, because that meta table is assigned, it looks at whatever the index is, and just pulls whatever's in.
Yeah. So if you look at this new character table, it doesn't have an HP. It doesn't have a speed. Okay? And so if I were to go try and read, C1 dot HP, what's going to happen is C1 doesn't have an HP. Look at it. C1 is an empty table that was given a meta table and it was given a name value, key value. That's it. But what's going to happen is C1 is not going to have the HP key, but it does have a meta table with that index set up. So it's going to instead look at the character. Okay, does the character have an HP? And it's going to find it, and it's going to print that instead. Now, if we set an HP, okay, so if we try and write an HP value like we do in take damage, all right, this is where we write an HP value onto C1, and it changes. Because it changes, it's no longer grabbing the parent table's HP. It's now grabbing the actual child table's HP. And yeah, I know this is very confusing. The last thing I want to say here, and this is a big foot gun, all right? Do you notice how sometimes I am calling functions with dot, like character.new, table.insert, but down here, I am calling the take damage member function, the take damage instance function, with colon instead of dot. Do you see this difference here? That's a big deal. If I change this to dot, we're in a world of hurt, okay? Run this, boom, you just blown up. It says 15. Okay, hold on a sec. It says in 30, you called the problematic function with the dot, and everything exploded on line 15 because of this. Line 15, we die, all right? What's happening? Well, this comes back to the self-reference, okay? When you call a function with colon, you are automatically sending the table in as the first parameter to the function, i.e., you get the self-reference automatically by using colon. If I want to use dot, I can use it. It will call this function, but it won't send in the self-reference automatically. So I can either do it this way, or I can keep the dot, and I have to send in C2, the self-reference, manually. And when I run this, we're back in business, okay? So how do you remember this? This is awful, right? What's the difference between dot and colon? How do I remember which one is which? Well, you see this extra self-reference right here? That's what the extra dot is, okay? So when you see the extra dot, you say to yourself, oh, that's the self-reference that's going into the function so that I don't have to send it in myself, all right? Look at this line of code and realize how ugly it is. It's like C2.takeDamage, and then you have to remember to send in C2 because Lou is not going to assume that's what you wanted to do. Other languages will assume you wanted to send in the self-reference, otherwise you wouldn't have written C2. But Lua is not going to assume that. If you want it to assume that, you have to use ... You have to use the colon, not the dot. Yes?
What if you pass C1 self?
What do you think is going to happen?
I think C1 is
Yes, that's right. So if we call C2.takeDamage but send in C1, then the C1 table is going to be the one that becomes the self-reference, which means it's C1 who's taken damage here. And I can prove this to you. Let's do it. C1, and we'll run it. And look at that. Peach is totally fine, but Mario's taking extra damage. All right? Okay. You see what I'm talking about when I say you just need to spend some time with Lua? You will get used to this, and it will get into your permanent memory like it has with mine. There's a reason I was able to create this epic length test case. If you look in the resources folder, you can download this test case yourself. You can find all of these component types, and some of these are pretty involved. We've got components written in Lua that are all about transitioning to the next scene, right? Make that nice fade, right? We got a player component that's all about dealing with iframes and allowing us to take damage and rendering us, right? And playing music. We have a really fun one called Vision Cone or Cone of Vision. This is the component written in Lua that is responsible for every turn spawning in a bunch of red tiles in front of Markiplier or whatever character is chasing you so that you can see which direction they're looking and you can see whether you're about to be caught by them or not and chase and get chased. And we got functions in here and we got all sorts of crazy business going on. This is a long ass file. Okay, we've got different components being added on and turned off just willy-nilly, like at runtime. We've got a big data structure for checking whether there's a blocking tile at a certain location. We have some math that's being done to determine if we have line of sight all the way out to a particular coordinate. Whew, all right, you'll get there. All right, you'll get there for sure. But again, what I recommend is embrace this. Have some fun learning a legendary new language. It's very tiny. I think you will grow to like it, even if it makes some things a little bit annoying. And with this inheritance stuff, it's going to click soon, but you might have to play around with it a little bit. Don't be afraid to kind of ask your AI assistant or bring it to office hours and ask me, and I can draw it out for you. That helps out a lot, actually, drawing it out. In your C++ code, we give you the C++ function that establishes inheritance between two tables. You just need to know that you need to use it and what it's used for. Okay? We'll talk more about all of this and how to structure your code base generally in the upcoming lectures and discussions. So don't feel too pressured right away. What I recommend doing is doing what we didn't get time to do, which is go to the assignment and then get some very basic Lua code running in your C++. Literally just a hello world from Lua. You will have to compile Lua, and you'll have to bring the header files into your project. And then you should be able to write something like this. You'll create a Lua state. You'll open some default libraries on that state. That gives you functions like print. And then you will run a string or a file. On that Lua state, the Lua state is important because that's where all your global variables are and your tables and your functions are. And then you'll tell that state that you want to run a line of Lua in that state. And boom, you should see hello from Lua print in the console. That's going to be a very special feeling. Okay? See if you can get the Lua embedded and just some basic sample lines running in your engine in the next couple days. Okay? And then on Wednesday, we'll talk about it more, and I'll see if I have time to do it in front of you, just so you can see it. And we'll get Lua Bridge in there as well, and I'll explain what that's for. Any questions or comments? Okay, good stuff. All right, I hope you enjoy homework 7. You will enjoy it a lot more if you start on it early and just kind of poke at it a little bit early so that you don't save it till the final week, all right? It really just takes time and some good sleep to make everything click, and it will click, and then you'll really enjoy what Lua can do for your engine. All right. I'm going to be here for the next 2 hours. So if you want to get rolling or want a better explanation of what's going on, then let me know. Okay. And I'll just be sitting here. Okay. All right, everyone. See you Wednesday. Everyone online, I will see you later as well. Take care. Bye-bye.